In this video, we're gonna focus on questions and answers on calculus. So we have this question here. Okay, they said let f of s is equal to sine inverse of s. Find f prime of 0. All right, now let's understand this question first before we solve the equation. Solution first. Now, class, we are given f of s as sine inverse of s, and we are asked to find this, class. Let's understand what this thing mean. Okay, now, class, whenever you have something like this, f raised to the power of -1 of s, this is inverse of a function. Whenever you have f raised to the power of, we call it prime of s. This is called derivative, or you call it differentiation. Please take note. So what we have here is differentiation. Please take note. So we are asked to differentiate this expression here, or this function here. We are asked to differentiate this function here, or this expression here. So now let's differentiate that function, class. We have the function to be, class. We have the function to be f of s is equal to sine inverse of s. So before we find f prime of naught, we have to find f prime of s first. Please take note, okay? Now, how do we do that? First of all, before we do that, class, let's change this function here as a letter. How do we change a function as a letter? A function as a letter, we say that function can be defined as y equal to f of s, meaning that to write a function as a letter is y. To write y as a function is f of s. Please take note. So we have to replace this to be y is equal to sine inverse of s. Now, class, this is what you have to understand here. This is what you have to understand here. Whenever you are given a equation or a function to differentiate, the first thing to do here is to identify the function. Each of the function have their pattern of differentiation. Each of the function have their pattern of differentiation. Though I have posted a video on functions and their derivatives, all you have to do is to hit the subscribe button to get that particular video. Okay, now each of the function have their pattern of differentiation. Okay, now we have to identify this function here. This function here is trig. Whenever you have sine, cosine, tan, sec, cosec, cot, they are all trigonometric. Please take note. So for us to differentiate any trig, we have to know the special function and their derivative. Now, what are the special function and their derivative? We have something like this, class. This is y. This is the y over the s. For sine s, you divide the s of sine s is cos s. For cos s, you divide the s is what? Minus sine s. For tan s, you divide the s of it is sec square s. For sec s, you divide the s of it is sec s tan s. For cot s, divide the s of it is minus cos sec square s. For cos sec s, divide the s of it is minus cos sec s cot s. So this is what you have to know, class. Now, these are special functions and their derivatives. So you have to know this. So if you look into this question here, this question is not in this format. We don't have anything as sine inverse in this special function. So, but we have to make this to be linear. How do we make this sine inverse to be linear? In order to differentiate it in this way, is to write it in this way, class. Remember, if I have this to be sine theta equal to 0.6, theta will be equal to class sine inverse of 0.6, meaning that this part here is equal to this part here, or this part here is equal to this part here. Please take note. This is equal to this is equal to this, or this is equal to this. So now let's write this in that way. So writing that, this is going to be something like this: sine y is equal to s. So if you make y the subject, you will get back sine inverse. So let's differentiate. To differentiate here, I have to differentiate this part and also differentiate this part. But we are differentiating with respect to s, meaning that whenever you see any variable as y or any letter that's not of s, you differentiate that and attach the y ds to it. But whenever you are differentiating y, you differentiate y completely. We call it implicit differentiation. So class, let's differentiate this guy here. So this will be class cos y, since it's not y, s, since it's not s, we attach the y ds to it. That is the y over the s is equal to, differentiate this will be 1. Okay, now let's make the y ds the subject. When you do that, we have something like this class. The y over the s will be equal to 1 over cos y. But remember this, whenever you are differentiating with respect to s, that means the letter that will be at the right hand side must have letter of s. If you are differentiating with respect to s, that means the letter that will be on this side here, this part here, must be of s. So if you look into this question here, it's not of s. So how do we make cos y to be in form of s? So we record that. Please take note. From trig identity, that sine square y plus cos square y is equal to 1. Please remember this, okay? So making cos, since we are looking for cos y, making cos square y the subject of formula for now, cos square y will be equal to 1 minus sine square y. But remember, we're not looking for cos square y. We are looking for cos y. So our cos y here will be equal to square root of 1 minus sine square y. Class, remember this also that note that from the equation that sine y is equal to s. So anywhere I see sine y, I will place s. But remember this, that sine square y is the same thing as sine y all squared. If I have sine square theta, is the same thing as sine theta all squared. So this and this is the same. So if that is the same, it means that this sine square y is the same as sine y all square. And anywhere I will see sine y, we replace that as s. When you do that, I will have cos y to be equal to class square root of 1 minus, which is sine y all squared. Okay, now replacing this sine y as s, I will have my result to be square root of 1 minus s squared. Okay, so anywhere I see cos y, I will replace cos y as 1 square root of 1 minus s squared. When you do that, our dy over ds will be equal to class 1 over cos y. Remember, this will be equal to class 1 over square root of 1 minus s squared. But we are giving the value of s from the equation. Remember this, that f prime of 0 is the same as dy over ds. So this f prime of 0 means that the value of s is equal to 0. So when you replace that, this will be equal to class 1 over square root of 1 minus 0 all square. And 0 all square is 0. So 1 minus 0 is 1. I will have it to be 1 over square root of 1, which is equal to 1. Please take note. So all you have to do to get the next question on question and answers on calculus is to hit the subscribe button. Okay, thank you.